There is no countdown, no alarm, no flash of light you could see even if your instruments were perfect. One moment, the atoms of your body obey one set of physical laws. The next moment, they do not exist. Not because they were destroyed, because the universe has adopted a different set of rules, and those rules do not include atoms like yours. The mechanism begins smaller than any particle we can measure. It starts at a single point, at a random moment, in a random location with no trigger. And then it expands at the speed of light in every direction forever. Nothing it passes through remains as matter, and because it travels at the maximum speed the universe permits, no information about its existence can arrive before it does. This is vacuum decay. Physicists cannot rule out that this process has already begun somewhere in the universe, right now. There is a specific reason why you cannot check, and it has nothing to do with the limits of our instruments. We will get there. To understand what is coming, you need to understand what the universe is resting on. Every cubic centimeter of space, including the space inside your body right now, is filled with quantum fields. This is the most precisely confirmed claim in all of physics. These fields form the substrate from which matter emerges. When physicists describe particles, they are describing excitations in these fields. An electron is a localized disturbance in the electron field, which extends through all of space. A photon is a ripple in the electromagnetic field. Beneath all of it, threading through every cubic centimeter of the observable universe, is the Higgs field. Not the Higgs boson, which is a temporary excitation of the field, a brief disturbance you can create and detect if you collide protons with sufficient energy. The field itself. Paramount, present, everywhere. Right now, inside the room you are in. The Higgs field is load-bearing. The field has a value, a constant background level, and particles moving through space interact with that level. That interaction is what produces mass. Remove the Higgs field, or change its background value, and the elementary particles that compose your body lose the mass they currently have. The quarks inside protons and neutrons would have different masses. The delicate balance of forces that allows protons to remain stable over billions of years would be disrupted. The entire hierarchy of atomic structure, the chemistry that makes biology possible, the molecular bonds holding every protein in your body together right now, all of it depends on the Higgs field sitting at the value it currently has. The Higgs field is the foundation. And the question that came into sharp focus after 2012 is whether that foundation is the actual bottom or whether it is a ledge. In quantum field theory, the vacuum is defined as the lowest energy state of a field. The Higgs field, like water, tends to settle at the lowest available energy state it can reach. The field fills space at a constant background level, and that level is determined by where the potential energy of the field is minimized. Picture the potential energy of the Higgs field as a landscape. The field settles in a valley. Our vacuum, the state of the Higgs field that has persisted since shortly after the Big Bang, corresponds to a specific valley in that landscape. Particles interact with the field at that valley, acquiring the masses we measure. The question is whether that valley is the only valley, or whether there is a deeper one, separated from ours by a wall of potential energy. In 2012, the Large Hadron Collider at CERN confirmed the existence of the Higgs boson with a mass of approximately 125 billion electron volts. That number carries information about the curvature of the Higgs potential landscape at our current vacuum. It tells you something about the shape of the ground you are standing on. A 2013 paper by Buttazo, Degrassi, Giardino, Giudice, Sala, Salvio, and Strumia fed that measurement, combined with the most precise available measurement of the top quark mass, into the equations governing the Higgs potential. What the calculation returned was this. With central values of those parameters, our vacuum sits in a region physicists call metastable. This must be stated with precision. Metastable does not mean unstable. A metastable system is locally stable, but it occupies a local minimum rather than the global one. Nothing is pushing it.
Given a small perturbation, it returns to its current state. But a deeper minimum exists, and if the field ever crossed the energy barrier, it would fall to that minimum and stay there. Think of a marble resting in a small depression on the side of a bowl. It sits. It is stable against small vibrations, but the true bottom of the bowl is lower, and if the marble ever crossed the rim of the depression, it would fall all the way down. This is what the Higgs boson mass measurement suggests about the vacuum we inhabit. We may be in the depression. It must also be stated plainly that this is speculative. The uncertainties in the top quark mass measurement are large enough that absolute stability, meaning our current vacuum is the true minimum, remains physically possible. The calculation does not prove metastability. It places our vacuum in a region consistent with metastability, given current experimental data. Physicists are not issuing evacuation orders. The standard framing in the literature is that we exist near the boundary between stable and metastable, with substantial uncertainty in either direction. What the calculation cannot rule out is the possibility that we are on the ledge. If our vacuum is metastable, a consequence follows from quantum mechanics, with no exit. In quantum mechanics, a system in a metastable state will eventually tunnel through the energy barrier to the lower state. Quantum tunneling requires no cause and no external push. It is a probability the field accumulates continuously, and in a universe large enough and old enough, probabilities greater than zero become events. The mechanism for vacuum decay was worked out in detail by Sidney Coleman and Frank DeLucia in 1980. Their framework describes how a bubble of true vacuum would nucleate spontaneously. At some random point in space, the Higgs field quantum tunnels through the energy barrier. A tiny region, possibly on the scale of the Planck length, transitions to the lower energy state of the field. Inside that region, the Higgs field has a different value. The physics inside it is different, governed by altered parameters arising from a different ground state. And then the wall of the bubble begins to move outward. It moves at the speed of light. The Coleman-DeLucia formalism predicts this precisely. The bubble wall is a phase boundary, a thin region where the Higgs field transitions from one value to another. That boundary propagates outward at c, driven by the energy difference between the metastable vacuum outside and the true vacuum inside. Mass, gravity, and every physical force the universe contains, none of it slows the wall. It expands indefinitely, at the speed of light, in all directions from the nucleation point. Inside the bubble, the Higgs field sits at its true minimum. The masses of elementary particles are different from what we measure. The forces that govern nuclear structure are different. Chemistry, as a concept, cannot exist in a region where the fundamental parameters of physics have changed. The bubble interior is cold and structureless in the deepest physical sense. Energy exchange, atomic collision, self-organizing complexity. The new physics permits none of it. Now consider what the bubble wall does as it passes through matter. It is a discontinuity in the value of the Higgs field, propagating at the speed of light. On one side of the wall, the Higgs field has the value it has had for 13.8 billion years. Protons are stable, atoms exist, chemistry works. On the other side, the Higgs field has a different value. Protons do not hold together. Atoms do not form. Chemistry does not apply. The wall passes through the region of space your body occupies in far less time than any biological signal can traverse your nervous system. The wall converts rather than destroys. Destruction implies wreckage, something that could, in principle, be reassembled. What the wall leaves behind is a region where the concept of a U-shaped arrangement of matter no longer applies. The boundary passes through. On the far side, you are simply not a configuration the new physics permits. And here is where the physics does not let you negotiate. If this is the first video you have found from this channel, subscribe before the next section. What follows is the part of vacuum decay that no instrument in existence can help you with. The bubble expands at the speed of light. This single fact carries an implication so absolute that it requires direct statement. Light is the speed limit of the universe. The universe allows nothing to propagate faster than light. Every signal, every wave, every physical effect of any description is bound by the same ceiling. This is a property of the geometry of space-time, built into the structure of what the universe is at a level beneath any particular physical law. Consider what this means for a bubble expanding at exactly light speed. The nucleation event, the moment the bubble appears, emits light. That light travels outward from the nucleation point, but the bubble wall also travels outward at the same speed. The light from the nucleation event and the bubble wall travel together. They arrive at the same moment. There is no gap between the news of the event and the event itself. You cannot receive a warning because physics does not permit one. The bubble and the warning travel at the same speed. They are the same event. When you detect the bubble, you detect it simultaneously across every atom of your body, because the wall is thinner than a proton and crosses your nervous system faster than any biological signal can propagate through it. There is no observation you could make today with any instrument that exists or could exist that would tell you whether a vacuum bubble has been nucleated somewhere in the universe. The bubble is the only signal, and the bubble moves at c. There is no advance information. There is no precursor. There is nothing you could monitor. Consider the geometry of the problem. The observable universe extends roughly 46 billion light-years in every direction from Earth. Every event in our past light cone, meaning every event that could in principle have sent light to us in the time the universe has existed, occurred within that volume. If a vacuum bubble nucleated at any point within our past light cone, it is already expanding. If it nucleated far enough away, it may not reach us for billions of years. If it nucleated more recently or closer, it may arrive sooner. We cannot calculate which, because we do not know whether it happened or where. We are incapable of detecting our own erasure in advance. That incapacity is a feature of the mechanism, woven into the physics of how the bubble propagates. There is no instrument fix. There is no future technology that changes this. The bubble outruns all news of itself by definition. Physics gives a framework for estimating how often vacuum decay might occur. The relevant quantity is the decay rate, the probability per unit volume per unit time that a bubble nucleates at any given point in space. Under the Batazzo et al. Calculations, assuming metastability with central parameter values, the vacuum lifetime is estimated at roughly 10 to the power of 100 years. The universe is approximately 1.38 times 10 to the power of 10 years old. The ratio of the current age of the universe to the estimated vacuum lifetime is something like 10 to the power of negative 90. Against this, the probability that decay has occurred anywhere in our observable universe since the Big Bang is, by current estimates, extraordinarily small. This is the point where another channel would offer a release. It would tell you that the timescales are so vast as to be irrelevant to any human concern, that the sun will long since have burned out, that your species will be extinct or transformed beyond recognition long before the probability becomes appreciable.
and that you can therefore relax. The universe does not organize itself around what matters to you. The estimates depend on the central values of measurements that still carry significant uncertainty. The top quark mass has been measured at various values by different experiments, and the spread in those measurements affects the stability calculation by many orders of magnitude. A different central value for the top quark mass shifts the estimated vacuum lifetime dramatically in either direction. The calculation is precise given its inputs, but the inputs are not yet precise enough to resolve the question. More fundamentally, probability and certainty are not the same thing. The decay rate is a rate. A low probability event remains a possible event. Vacuum decay, if it occurs, does not politely wait for a future so distant as to be irrelevant. It can occur anywhere in space, at any moment, entirely at random. Low probability events happen. Every event you know of is low probability against
The background of all events that could have happened instead. And here is the calculation the universe does not provide: whether decay has already occurred outside our observable volume. The observable universe, the sphere of space from which light has had time to reach us, is finite. Beyond it, the universe continues. Under current cosmological models, it is likely vastly larger than what we can observe, and possibly infinite. In a universe that is infinite, any non-zero probability becomes not merely likely, but certain. Vacuum decay may have already occurred repeatedly in regions we cannot observe and will never observe. Bubbles may be expanding right now in portions of the universe that are beyond our cosmological horizon and that will never intersect our position. Or they may intersect it. We are working inside a finite observational window on a question of potentially infinite scope. The probability that decay affects us may be extraordinarily small. The number is greater than zero, and we cannot measure it precisely enough to distinguish between extraordinarily small and simply not yet. One more property of vacuum decay requires attention because it separates this end from every other end the universe permits. When a star dies in a supernova, it leaves a remnant, a neutron star, a black hole, an expanding shell of gas seeded with heavy elements forged in the stellar core. Future generations of stars form from that material, future planetary systems, future chemistry. The death of one thing generates raw material for subsequent things. The universe is a system in which the endings of things become the raw material for beginnings. Vacuum decay does not work that way. When the bubble wall passes through a region of space, the Higgs field in that region transitions to its true minimum. The new physics contains matter as a feature nowhere in its landscape. The particles that existed in the old vacuum do not scatter. They do not become something else. They cease to be configurations the new physics supports. The energy of the old vacuum is absorbed into the new ground state, leaving nothing behind in any form we could recognize as a remnant. Every star in the observable universe, every black hole, every galaxy cluster, every photon crossing the intergalactic void, every arrangement of matter that has assembled itself across 13.8 billion years of cosmic history, stars igniting, collapsing, exploding, seeding new systems, the entire chain from hydrogen to carbon to life, to the moment you are watching this, all of it, converted, not destroyed, converted into whatever configurations the new physics permits. And those configurations bear no resemblance to atoms, molecules, or any form of complexity we have concepts for. There is no record. The medium on which any record could exist ceases to be a viable structure. The new vacuum does not include the concept of a substrate on which history could be encoded. The bubble does not stop at galaxies. It does not slow when it encounters mass.
It does not run out of energy because the energy driving its expansion is the difference in vacuum energy between the old state and the new. And that difference persists for as long as the old vacuum persists outside the bubble. The expansion is self-sustaining, indefinite, at the speed of light, without end. One event, one point in space, no trigger, and then an end with no subsequent beginning. You are sitting inside the Higgs field right now. You always have been. The atoms of your body have their masses because of that field. The chemistry of your cells, the electrical signals in your nervous system, the bonds holding every molecule in your body together, all of it depends on the Higgs field sitting at the value it currently has. The question physics has not resolved is whether that value is the true minimum of the field or whether it is a local minimum that persists only because the quantum tunneling probability has not yet been realized at any point in our causal neighborhood. We do not know. The measurements we have place us near the boundary between stable and metastable, with uncertainties large enough that either answer remains possible. If we are in the metastable region, there is a bubble. Perhaps it has not started. Perhaps it started a billion years ago, 10 billion light years from here. We do not have the ability to tell the difference. The mechanism that would tell us is also the mechanism that ends us,
And it arrives at the maximum speed the universe permits. It is above you right now. The potential, the probability, the question of what the Higgs field is resting on at this moment in every cubic centimeter of space you occupy. You have no way to look at it and know whether the ground is solid or whether you are standing on something that has a lower floor. The field has simply not found yet. If you found this channel because the physics here unsettled you, subscribe and leave one answer in the comments. If the bubble is already in motion right now, is knowing that better or worse than not knowing? The same uncomfortable physics that governs the vacuum beneath you also governs the large-scale structure above you. And there is a place in that structure that should not exist by any model we have. The Buotus void should not exist. Here is what that means for you. It is on the screen right now. Tap it and keep watching.